Complex systems drive the technology of daily life. However, the efficient design of these systems requires modeling and simulation. For that purpose, Simulink enables us to visualize the flow of information and the relationships between components in our models. But what exactly is Simulink? To answer this question, let's assume we're trying to design a quadcopter controller. To represent this real system, we would start by creating a mathematical model of it. Traditionally, this involved translating our model into computer code, which could take a lot of effort as the complexity of the system increases. Back in the 90s, MathWorks developed a visual way to represent and solve dynamic systems. By dynamic, we mean a system that is changing over time. Simulink was designed to mimic the types of diagrams used by engineers to depict control systems, and this approach can be extended to any kind of dynamic system. We represent the different interconnected components that make up this device using a block representation. So, what is Simulink? Simulink is a block diagram environment used to model, simulate, and analyze dynamic systems. Now, if we look closer, this complicated system is actually broken down into a series of subsystems. Within each subsystem, we have common individual components. There are input signals, blocks that define some operations, and outputs. This approach allows us to better build and organize the different elements needed to model a complex system. Once we've built the model, it's simulation time. We run a simulation by simply clicking the Run button. In Simulink, simulations are performed using a series of discrete time steps until a final simulation time is reached. At each time step, the blocks in the model update their output signal values. We can also visualize the results of our simulations. In our example, we see a series of time traces for various properties of the quadcopter as the simulation is run. And, using Simulink, we can share the design with others in a standard block notation, so they can also check these results. We can configure our model to have just the right amount of detail in order to explore how our model works under many different conditions, and then iterate on the design before building a prototype. Once we're happy with our model, we can go one step further and generate code to deploy onto our quadcopter and test in real time. Pretty cool, huh? Using Simulink, we can build the model, simulate the controller, and eventually deploy code to our target. This approach helps us to continuously validate our design. Simulink is used in a wide range of applications that include controls, robotics, signal processing, communications, and many others. For example, we can design a smart wind turbine that adapts to wind conditions. Or design and deploy code to a robot that can analyze its surroundings to avoid obstacles. Or even design and control the temperature of a smart house. The possibilities are endless. So, what are you going to build? Whatever you choose, with Simulink, your projects can take off.